Hello everyone, my name is Barbara and I would like to welcome you to our latest Novedge webinar episode. This week, the future of design with Fusion360. See how a CAD tool written on modern architecture can change the way you create 3D geometry, more effectively connect your design, engineering, and manufacturing teams, and communicate data to both internal and external stakeholders. Today's presenter, John Peros, has made the leap into the future with Fusion360 after 15 years using traditional parametric software and hasn't looked back. His spare time is spent with fabricating vehicle parts, off-roading, and hanging out with his wife and 2 young sons. Before we get going, here's an overview of what we do in Novedge. Novedge is one of the largest online stores for design software. We offer a huge assortment of software solutions that cater to virtually every designer's needs. Put us to the test and come visit our webpage at novedge.com. And for more daily software news and limited time promotions, also pay a visit to the Novedge blog and follow us on Facebook, Google+, and Twitter. Coming up next week, organizing your document set with Bluebeam Review. Last but not least, today's webinar is free and is being recorded live. If you want to rewatch this or any webinar episode in our connection, just head on over to Novedge's YouTube or Vimeo channels. And now, if you're ready, John, I'll let you lead and take center stage. You should be able to see John's screens right away, and then I will fade away in the distance. Here you go.
Sounds good. Thanks, Barbara, and good morning, everybody. My name is John Peros. I work at Autodesk. I am a technical specialist on the Fusion360 team. And so I'm going to give you sort of an overview today of Fusion360. And, as Barbara read sort of the introduction to this webinar, it's important, really, one thing that she mentioned, which is that this is a tool that's written on modern architecture. So you got a lot of CAD systems out there in the market today, and the majority of those CAD systems, especially the top players, are written on code that averages about 25 years old. And so there's actually a lot of things that those CAD systems can't do in terms of leveraging modern computing patterns. So Fusion is a ground-up CAD system rewrite. This is not a port of our Inventor product or any of our other CAD products here at Autodesk. This is a full from-scratch rewrite of what we think CAD should be going into the future. And doing a from-scratch rewrite allows us to change a lot of things about the way CAD works. So, for instance, we're able to add completely connected cloud data storage and collaboration. We're able to fully utilize multi-threaded CPU processing. We are able to really change a lot of the way that CAD design works in terms of I do this because the CAD system tells me to do it this way, instead of I want to design this because this is the way I want to design it. So you've got a lot of really cool stuff going on in Fusion. I'm going to try to cover as much as I can here in the next 45 minutes so we leave some room for questions. Starting off with CAD, because hey, you can't be a CAD tool unless you make geometry. There's something that's really unique about the way Fusion360 does its geometry. So currently, there's 3 different ways of doing CAD on the market. There's your traditional sort of parametric CAD system, your Inventor, your SolidWorks, your Pro Engineer. That is the predominant way of designing geometry today. That's a history-based system with features and sketches and all that stuff that you guys are probably familiar with. There is another modeling type called freeform modeling. This is similar to an Alias or a Rhino if you've ever used any one of those systems, which is really more of a push-pull surfacing tool. Great for creating really complex surfaces, not so great for creating mechanisms and parts that require high level of accuracy. And then the third type is a little bit more obscure. It's called direct modeling. You'll see this in things like a space claim or a co-create. And that's used a lot of times for geometry repair. And so what Fusion has done is said, listen, all these types of techniques have their merits and they have their downfalls, But having to switch between different systems in order to utilize each technique is a real burden. So we're just going to do everything in one system. So Fusion's really the only tool on the market that is a parametric tool that also allows you freeform modeling and direct editing capabilities inside that parametric environment. And so it's really revolutionary from a geometry creation perspective because of that. And so if you look at this example that I have on the screen, this is a reciprocating saw, and you can see that this reciprocating saw has a very complex housing. And for those of you who are familiar with doing surfacing in parametric CAD tools, think about the loft profiles and the guide curves that you would have to utilize to get a shape like this. It's not a pretty picture and it's not easy to work with. But on the flip side of that, I've got a completely mechanical assembly in here too. You know, I've got joints and links and brackets and motors and gears and stuff that is very mechanical in nature that I'm going to need to do some sort of motion on and check the limits and things like that. And I want to be able to design this whole product fluidly inside of one system. And so that's what Fusion gives us. So if I were to hide the existing housing for the time being and pull up sort of some concept art, I'm going to walk you through some of the freeform modeling tools that Fusion has and show you how we can utilize these inside of this parametric environment. And so in Fusion, when you want to do some complex surfacing, you simply swap over into our sculpting environment. That's what we call our freeform modeling tool. And you're going to see that nothing in the interface changes other than the fact that you get a different set of tools up at the top here. Now the one thing that I want to point out that's really important is a freeform modeling feature has also showed up in our timeline. You guys might be used to a feature history tree over here in the left-hand side of the screen. We're going to do the same thing in Fusion. We just call it a timeline and we put it at the bottom of the screen. But this is a timeline of how this assembly was built. And I'm a 15-year SolidWorks user, as you guys might have seen in my profile there. So if I use a SolidWorks terminology here and there, you'll have to forgive me. I've been doing Fusion for about 1.5 years now. But so we're going to move forward with this, and there's lots of different ways to start your freeform surfaces. I'm going to start with one that's very simple in that I am going to create a face that is just a four-sided face. So I'm going to click 4 points here in the screen, and this is going to drop off a face for me, and that's what I'm going to utilize to start the design of this housing. Now I've got the ability to completely manipulate this face in space utilizing translation commands, rotation commands, as well as scalar commands. So the first thing I'm going to do is I'm going to pull it to the outside of that mechanical package to make sure that I'm going to encompass the whole thing. And then when I've got it where I want, if I don't want to look at that mechanical package, I've got a great way of selecting all those components and hiding them so that I don't have to look at them right now. Okay, and then I'm just going to start manipulating this guy. So using these push-pull handles that you see in the interface, I'm able to start adding to this surface and very easily manipulating the shape of this surface in 3D space. And I'm just starting to get sort of the basic shape of what I want to accomplish here on this housing. And so I can utilize a number of different tools here. You know, I can stretch, I can rotate, I can translate. I've got these scalar commands, which a lot of times are really great for lining edges up, right? If I scale to 0, that will actually line edges up in the direction that I'm scaling towards. So this is a really easy user interface, especially if you've never done a level of surfacing before. Doing surfacing in a traditional parametric tool requires a lot of specialized skills and tools, and it's not that discoverable by the average user. This is really like having a piece of clay in your hand and getting to push it around until it looks like what you want. Now, utilizing the background image, I can tell that the back half of this handle is a little bit more round in shape, and so instead of having to pull this over and push it into a round shape, I can actually bring multiple shapes into this design. And so I can just start a very basic cylindrical shape over here, and I can move it over towards that handle in an effort to connect these two shapes together. So I don't have to work with one piece of material and push, pull, and stretch it the whole time. I have the ability to utilize multiple different pieces of material here in order to get the results that I'm looking for, right? So maybe we could scale that up a little bit, set it where we like it, and then move forward utilizing these two bodies. If I don't need the back half, it's easy for me to delete that inside the system, because you see that what the subdivisional modeling tools in our sculpting environment do is they chop these surfaces up into little faces. So I can delete any number of those faces that I need to in order to move forward with my design. Now what I can do is take a couple of these faces and just start to pull a little tab off. And you can probably see what I'm starting to do here is I'm going to build a connection between these two bodies. But one of the things with subdivisional modeling is you want to match faces. So I've got two faces over here and only one face here. We utilize a special mathematics inside of Fusion called T-splines, which will allow me to insert finite detail in specific regions of the model, creating essentially a T-junction. That's what this point is right here. It's a T-point. T-splines is the only mathematics in these freeform type of tools that can solve the curvature at a T-point like that. So in other tools, I would have to continue the detail all the way up the model, and I would end up with detail that I don't need. And the more detail you have, the harder these models are to control. So again, from a basic surfacing perspective, this makes it really easy to learn how to surface inside of Fusion. Now we've got all sorts of other tools in here, so I'm going to use a tool called Bridge, and what this is going to do is figure out how to connect these two surfaces for me, and it's going to build that bridge. And then if I don't like that, that's fine, because it's still just my sculpting environment, and I can come and adjust the interpreted surfaces that it put in there until I get them looking exactly like what I expect. And, you know, one of the things that you'll find with this subdivisional modeling and a lot of feedback we get from customers is that this is sort of a cathartic process, in that it's very relaxing to have this much control over a model without having to worry about sketch entities and relations and things of that nature. So you can find yourself often spending a lot of time in here making these minute adjustments, getting this surface to look just perfect without having to worry about the traditional relationships and references and pierce points that you might break. And the result, I think, is most often you're going to get a better looking surface here in Fusion because you're more comfortable making the edits to that surface than you would be in another tool. And so as I continue doing much of the same here, I'm going to build some surfaces around this handle. Notice that I can use my rotates and I can use my scalars, and I can really start to manipulate this surface to what I expect to see. And like I said, I can do as much or as little of this as I want to in order to get the result that I'm looking for. So I'm going to get this guy over here and rotate it up straight, and then I'm probably going to move a couple of these surfaces. You know, I'm just matching to this background image that I have. Now the nice thing that you'll see in Fusion is that it's maintaining watertight surfaces as I go about this, and that's something that if you're a Rhino user or an Alias user, you'll notice is a little bit different, because in Rhino or Alias, as you're creating these complex surfaces, it's actually really easy to end up with surface gaps, so that if you were trying to use that as a solid body later down the road, you're not going to be able to because you have gaps in that surface. So Fusion is maintaining the watertight completeness of this surface automatically for you. So again, it's just one of those things that, especially as new surfacing users, you don't have to think about as you're moving forward with your designs. The other thing that it's doing for you is it's maintaining a level of continuity that's often referred to as G2 continuous. And what that really means is that it's maintaining a better than tangent continuity across your surfaces. So you're always going to end up with very smooth, continuous surfaces when you're doing these models. To illustrate that point, I've actually created a surface here that has a gap in it. I've done that manually and on purpose so that I can show you this. But watch what happens when I connect these two entities together. So as I weld these vertices, you will see that Fusion is now calculating the continuity between the two surfaces, and it's solving for that smoothness automatically for me. And so if you pause for a second and you look at what we've done, we've created an incredibly complex organic shape here in less than 10 minutes. And this is something that I have full control over utilizing my manipulation tools, not having to worry about sketches and pierce points and all the relationships that go along with that. Now there are some higher levels of control in this tool. So for instance, I'd like to mirror this, but I don't exactly have all the mirror edges that I'd like on the mirror plane. And so Fusion provides you with a number of different commands that you can utilize to get more control out of these models. So in this case, I'm going to be able to pull those vertices to my mirror plane. And now if I mirror, I'm going to have a perfectly seamed body. However, one of the things when you mirror that's very important is tangency. And I obviously don't have tangency at this mirrored boundary. So if I was to mirror this in a regular tool, I'm actually going to see an edge there. It's an edge that I can see. It's an edge that I can feel. It's something that's not going to make this very nice looking. And so I want to ensure that I have tangency at that boundary. Now in other tools, you have to control that via sketches and guide curves. In Fusion, it's automatically controlled for you during the mirror process. So as I mirror this body across that plane, it automatically solves the tangency for me. And in fact, this goes into C2 continuity, which is even better than tangency continuity. And so across that boundary, I've got a completely smooth connection with no seam that I no longer have to worry about manually trying to achieve. And so the other thing that this does for me is it gives me live symmetry. So when working in components that have symmetry from left to right or front to back, if I make a change on one side, I'm actually going to see that change now happen on both sides of the model at the same time. So this gives me a lot better feel for what my model is ultimately going to look like instead of making a guess and then mirroring to see what it looks like. It's just a lot of really cool tools in here in terms of creating these surfaces. Now, one of my favorite things about Fusion is the ability to iterate. So if I get this shape, and I'm really kind of very happy with this base shape, but I want to try a couple other things out, I would have to take this file, do a couple save as's, and then I could go to those other copies and test out my theories. That way I know that I'm not interfering with this base shape that I do like. And then if I make a change, I have to worry about how do I get those changes back? Do I swap files? There's a lot of headache that goes into that. In Fusion, I can simply copy this body off, and then by doing a body copy, I've created something that's exactly the same as my starting point, but is now no longer related. And that means that I can come in and I can make changes to this copied body without having to affect the original body. So this way, I can come in and I can test out different iterations of this and really see what this thing is going to look like in a couple of different scenarios. Now, I'm going to pause for a second and I'm going to hit save. And normally when you're doing a CAD demo, you're not going to point out when you save, but a couple of really important things are going to happen. First thing that's going to happen is that this is going to bump a version. So this is a Cloud Connect tool. We're saving all our files up into the cloud, and one of the benefits of that is that the cloud can handle all the data management for me. So by doing a save, I'm going to get the ability to put in a note here, shaping, handle, whatever I want to put in there, and it's going to automatically bump from a V3 to a V4. Now you'll see that as the save is happening, the Fusion interface is still completely active. So if you guys are using a traditional tool, you've probably noticed, especially with larger models, that when you do a save, your CAD tool is not active during that save because those old tools can't utilize multi-threading technology. Here in Fusion, when we do a save, it spawns off a new CPU thread, and it does the save on a different thread than the CAD tool's running on. So even if that save takes 10 minutes, you don't have to go get a coffee. You can keep working in your CAD system. That's one of the huge advantages of being written on a modern architecture. Another advantage of that is our cloud-connected collaboration. So if I take this model now, and maybe I'm not the decision maker, I want to get some input from someone else at my company, I can bring up this commenting pane and I can say, hey Sam, what do you think of these handles? And I can even post a screenshot out there, and what this is going to do is it's going to post that question out into our project area. Now, with this out in our project area, you can sort of see an example of what's in the project area inside Fusion. So I've got the ability to tell what files are in here and what people are in the project with me. But the people who are in the project with me, in this case myself and Sam, is actually going to describe what people can do. So even though Sam is not necessarily a Fusion user, he's going to be able to get in here and consume my data and actually make suggestions to me. And look at that. Here's a suggestion. Sam says, I like the bottom one the best. Let's move forward with it. Now, here I am at my house today in Southern California. Sam is not here. He's in Denver, and he's able to make that comment automatically without having any Fusion license installed. He's just utilizing a web interface. And I'll show you guys that web interface here in a second. But what Sam has done is he's proven now that we can have a cross-country, across-world collaboration that's real-time because we're using this web-enabled interface. So Sam likes the bottom one. We would theoretically continue on with the bottom one now. If I hit finish form, what you're going to see is that it leaves that feature here in my timeline, and I have the ability to come back now and make edits to this feature whenever I want. I'm not going to make you guys sit here and watch me design the rest of this handle, so I'm going to go back to the handle that was already created, and I'm going to show you some of the stuff that we can do. So if you look at my timeline, I've got another one of those purple squares at the front, another one of those sculpt features, and if I roll back, you'll see that this whole housing was created with an initial sculpting feature. Right? So that looks great. They did the sculpt, and then they obviously put a lot of parametric stuff on top of this. And I can even play the history if you want, and you can see that the surface was here, and then it was capped and thickened and shelled and cut in half, and notches were put in it, and there's all sorts of stuff done, but it's all based on that initial sculpted surface that I did in the first place. So the interesting thing here is that I can now build parametric features on top of that sculpted surface and expect rebuildability if I change the sculpted surface. So for instance, let's put some ribs in here. Okay, so I'm just going to sketch out the location of a couple of ribs, and I'm never going to advocate to you designing sloppily, but I'm going to design a little sloppily here just to prove a point in Fusion. And I'm putting these lines out, and none of them are the same size or anything like that, but it doesn't matter when I'm doing a rib in Fusion, because when I use the command to create these ribs, Fusion is automatically going to find the boundaries for me, and it's going to take those ribs up to the boundary of that solid body that I'm working with. Now this is really awesome because, again, that's a parametric feature. If the boundary changes, we expect the ribs to update, and the boundary is based on that surface, so if I change that surface, I expect the ribs to update. And I'm going to show you guys that in a minute, but I'm going to put a few more features on here. So in order for the internal components to fit, we're actually going to need to create a cutout on these ribs. Notice that one of the things in my sketching environment is that I can actually dimension while I'm doing the sketches, which is kind of nice. It gives you a little bit better speed if you like to do that in your sketching environment. So I've got my dimensions all set out there, and I can do my typical extrude. You know, we've got a full parametric system in here, so if I want to extrude up to a face and create that relationship, this is stuff that you guys are very used to. And what I'd like to do is come in here and create some sort of fillet feature. And typical fillet features, you're going to want to go and you're going to want to pick all the edges that are associated with the fillets. We've got a really cool fillet feature in Fusion that instead of asking for edges, it's going to ask you for features, and then it's going to find the corresponding edges of those features. So here I am, I've chosen the two features, and it will go and figure out what edges belong to those features. Now, this is a really robust way to do fillets, because if I do fillets by picking edges and then the edges change or move or get deleted, my fillet feature is going to fail in a traditional system. If I use this feature in Fusion where I'm inputting the features, if I go and say take out this middle rib, I'm not going to see any error in that filleting feature because the filleting feature didn't ask for edges, it just asked for the feature. So it's always recalculating what edges belong to those features. If I was to put in this third rib, you're going to see that it gets filleted just as well. So this is a very robust way to do fillets and have nice rebuildability going down the road. A couple other things that are really cool in here is the ability to use our direct editing engine. And so the direct editing engine comes with model healing, and that model healing finds its way into pretty much all the features in Fusion. So let's take this middle rib for instance. If I'm in a tool, let's say SolidWorks, because that's where my history is, and I want to put draft on this fillet, I've done something very bad. And that is that I've filleted the edges first. Traditional parametric CAD systems can't draft faces if those faces terminate in a fillet. They just can't solve that. But back when I'm in engineering school, nobody told me that you can't have fillets on drafted faces. In fact, fillets are very common on drafted faces. So there's no engineering reason that I have to do draft first. That's a CAD system reason telling me I have to do draft first. And that's a rule that I need to know if I'm expected to utilize that CAD system properly. That's not the case in Fusion. Again, one of the reasons that doing a rewrite of a CAD system is so nice is that we can take some of those strange things out and we can make it behave properly. So if I want to do draft, even though these faces have fillets on them already, that's no problem. I can go grab my draft feature here and we can make sure that we choose the appropriate faces, and maybe I'll make this a 3-degree draft instead of a 1-degree draft. Oops, not a 0.3. Apologize for that. Let it go to a regular 3. And what you'll see is that this draft gets added to those faces with no issues, even though they already had fillets. What does it do? It just moves the fillets out. And that's because we have this awesome geometry healing engine. That's what tools like SolidWorks and Pro Engineer can't do today. That's why they can't do draft if you have filleted faces. They can't solve what happens to those fillets. So just a cool little tidbit of what's going on in the background. But some of the other stuff that the direct editing is useful for is things like overmolds. So here I've got a sketch that's going to tell me where I have a section that I want to do some overmolding on. And so what I can do is I can use a command Fusion has called split face. And if I change some of my selection tools, I've got a whole bunch of them here, so I only select outside faces. I can basically say that I want you to map that sketch onto those faces and split them so that they're now new and individual faces. Now that's awesome because then I can take those faces and I can simply tell Fusion that I want to grow them. So if we're going to do an overmold here, we want to take those faces and maybe grow them out 1.5 millimeters. And part of the direct editing model healing is that it can just grow those faces out. I didn't have to do a surface offset of 0 and then a thicken or any of those things that you might be having to do in a traditional system. All I had to do is grab the faces and say grow them. I can put a fillet on there, make it look nice, and that's great. That's easy. That's less headache for me to create this complex geometry, but it's still all based on that initial sculpted shape. So what happens if we change that initial sculpted shape? Well, let's go back and do a change. and see what happens. And I'm going to make a change here that's very obvious, may not be a real world change, but I want to do something that obviously indicates what we've done here. So I'm going to move a couple of these faces up and make them larger. Obviously, I've got ribs and things going on in these sections. You know, I can pull this thing down or pull it up, pull this outside up, whatever you want to do. You can see sort of where the old body is. So I'm obviously changing the parameters here. I could even go into this outside where we have that overmold and maybe pull one of these faces out. Okay, so some changes in there to this sculpted shape. And then what you'll see is that the body is going to rebuild. You can see it's parametric, it's calculating, it's rebuilding all the features right here. And what's going to happen is those ribs are going to update with the new boundaries. The overmolding is going to update, and everything is, well, that's interesting. That didn't quite update for me. I'm not too sure what happened there. Let me try this one more time because I think this is important to show you guys. Maybe I made a few too many changes there. Let me just take this and push it down just so that I can show you what's going on. So it's going to go through here. It's going to rebuild. We're going to see the boundaries change. And those ribs that we placed in earlier are going to update with the new boundaries. And so that's something that's very important in this tool. And you'll see what happened now is my fillet thinks that these edges are a part of it because that cut moved down. We moved the face down, it moved the cut down. It's now filleting the edges on the boss as well. And so Fusion is just calculating all this stuff. And even though I've got an error here, it's still rebuilding everything for me as it should. So go back now, just our normal tool, and I'm going to show you some other stuff. So this is not just a CAD tool. There is actually a lot of other stuff built into Fusion. So if I look at it, I'm in modeling mode right now, but there's still going to be render mode, animation mode, simulation mode, CAM mode. So simulation is going to be linear static stress analysis and thermal analysis. CAM is going to do 2.5 and 3 axis tool paths. And that is all built into this one single tool. And there's no packages for Fusion. Fusion is just Fusion. It comes with everything. So if I go into render mode for a second, you know, you've obviously got full control of the appearance of this model here in the rendering mode. I can go grab different appearances, and I can place appearances on faces, or I can place appearances on entire bodies. So maybe I want to go take this rubber overmold and I want to drag some weathered appearance onto those faces to make this look accurate. So it's very easy to get in here and create these appearances. You can also control the scene. So I can control the background, I can control the lighting, I can control the camera perspective if I want to do some artistic effects. I can even get in here and turn on depth of field, which would control things like blur. But when I get this model to the point where I'm happy with it and I want to render it, so maybe let's turn on my internal components as well so that I can see those in the rendering. I can hit the render button and it's going to use my local resources to calculate. So this is a cloud-connected program, and we haven't talked about the cloud a ton other than that we're saving the files up there. And that's because it does actually get installed locally to your computer. It is, by the way, supported on both PCs and Macs, and it runs on Macs natively. So if you like Mac, you don't have to run Boot Camp or Parallels or anything like that in order to have Fusion installed. You can just do it straight on the Mac operating system. So if you were in the room with me, you would hear my fan spinning up. It's going through, it's doing its iterations, and it's refining this image one iteration at a time. This is going to take a while. We say you want to do about 250 iterations until you get a nice clean image. And so I could go get lunch or a coffee and come back and have my rendering done. However, here's where I can also utilize the cloud. Computing in the cloud is almost infinite in a lot of scenarios. So I can do a cloud rendering now, and the cloud render basically asks me what size of image that I want, and it says, hey, we'll render this for you in less than 20 minutes. And it's going to render on the Autodesk servers. Now it tells you that this is 2 cloud credits. That's essentially the equivalent of $2. If you're going to use the Autodesk servers to do that rendering, they're going to charge you a little bit for it. But in essence, I've now got that rendering in the cloud, not utilizing any of my computer's resources, so that I can come through here and I can continue working on this model and doing other things instead of waiting for that rendering to finish. And there are some other things that I want to do in here. So if I come back into the modeling environment, we've talked a lot about sort of freeform shape creation and updating, and we've done some parametrics, with the ribs and the draft and all that kind of stuff. But I want to focus a little bit on motion creation. So we've got this mechanism in here, and this is obviously a motor that's going to drive this blade. And all these components are really just sitting in here right now. They've been put in place, but they haven't been told how to interact with each other. And I do that on purpose because it's very different in Fusion how we set up these interactions. In a traditional CAD system, you're going to be choosing faces and edges, and you're going to be telling those faces and edges how to interact with each other. In essence, you're removing 1 degree of freedom at a time from the model. In Fusion, what we do is we add a degree of freedom at a time. So instead of faces and edges, I'm going to say that this component and this component interact with each other in a revolute way based on that axis. And I'm telling it exactly how to behave in that one single command. And so we've got a couple other revolute relationships in here that we want to apply, but then I'm going to apply some other relationships as well. So the saw blade and the linkage have a revolute relationship, but the saw blade now has a sliding relationship based on this housing. So I can choose the slider and I can choose the edge direction, create that sliding relationship. If you wanted to create a rigid relationship, say between the clip and the pin here, you could set up a rigid and they're going to be fixed together just like that in that position. But I've essentially now created the motion that's going to allow me to move that linkage around, and I can even animate that if I want. So I could go put a motor on that animation and start turning everything and see exactly how it's going to function. That type of motion creation is the simplest motion creation I've ever seen in a CAD tool in my 15 years of using CAD. So this is pretty phenomenal from my perspective. But we've got all sorts of other ways to interrogate this model. So you can turn on collision detection by enabling contact sets if you would like to. And you can enable contact across the whole model, or you can enable contact across just 2 components if those are the ones that you're curious about. You can also turn on interference detection. So I've got a pretty obvious interference going on right here, and if I wanted to analyze that and see if it had interference, I can just grab those components and have it compute, and it's going to show me every spot they interfere as well as the volume of interference between those components. So it makes it really easy to interrogate these highly mechanical assemblies to understand exactly where parts are fitting and not fitting properly. So it's not just about creating fancy surfaces. This is a real full bolt mechanical engineering parametric CAD tool as well. It just happens to have the freeform surfacing built in so that you can do everything in one place instead of having to jump out. So let's talk about one other thing that I find really important in this, and that's the ability to do some sort of FEA analysis. So if I swap over to my simulation environment here, I'm going to be able to run 4 different types of studies: linear static stress, frequency analysis, thermal analysis, and then stress induced by thermal input analysis. So lots of different things that I can run here. If we go run a standard static stress analysis, one of the things that I like is the ability to isolate components only in the simulation environment, because if I isolate these in a traditional parametric tool to run a simulation, then the guy upstream using my component in an assembly now gets components where things are missing, and that's going to drive him crazy. But in Fusion, we only isolate in the mode that you're working on. So in model mode, everything's still there. In simulation mode, just these particular components, and that's pretty nice. So I could go apply materials if I wanted to. I can set up the constraints here, so I can say this is being held on these two bolt holes. We've got lots of different loads that you can apply. So if I was to apply a 75-pound force load here on this particular model, that's in newtons, which I don't understand, so I can change it to pounds. Okay, then we've got the ability to do all sorts of different contacts and the ability for automatic contact detection as well based on the ways you set up your preferences. So I'll run some automatic contacts, and then I can even get really deep into this. I can change my mesh settings. I can turn on adaptive meshing so that it's going to solve and then remesh and solve and remesh and solve and remesh until it finds a point of convergence. So all those really high-end finite element analysis capabilities are built into this if you're doing a linear static analysis. And so it's going to go through and mesh the model and solve. And the nice thing about this is that it's set up in such a way that it's easy to understand if you're not the quote-unquote FEA guy. You're not the guy with the PhD who knows how to run the FEA tool, but look at how fast I'm able to do this in Fusion. I realize at this point it's got a 0.52 minimum factor of safety, so it's going to fail under that given load condition. So instead of having to send this to my FEA guy and him sending it back to me, I'm able to figure this out first, and then I can still send it to him for final analysis. But hopefully this is easy enough that I'm going to be able to reduce the number of times he and I have to go back and forth with this model. And so this thing obviously needing some changes, I'm going to show you one last thing here in Fusion before I get over to the collaboration environment. And that is the ability to do all sorts of really high-level direct editing. So if I open this model right now, what we're going to see is that I don't have a feature history. So if I look at the bottom of this window, I don't have a timeline, and that's because this model is imported from another system. So when you import from another CAD system, you're obviously not going to have the feature history. What are you going to be able to do to make changes to this model? With all that really cool built-in direct editing, I know I've got an issue right here. This is where it was breaking. I can actually just grab that face and I can start to elongate it. And it's not just press pull however I feel. I can put numbers in here. I can say make that 8 millimeters longer. Right? Maybe I want to go onto the face on the other side and I want to make it a little bit wider so that it distributes that load a little bit better. No problem. I can make that face wider. Okay, and I can do all sorts of other things in here too. So if we look in this pocket, it's got like a really funky fillet. And that fillet, I don't know how anybody got this fillet on here, but that's obviously not an appropriate fillet for manufacturing. I can select the faces associated with that fillet, hit the delete key, and Fusion will just patch it out for me and fix that edge. And then I could go back in there and put my own fillet if I wanted to. Or you look at the back half here, we've got 2 support brackets. Well, maybe in our example, that's too much and that's going to drive up the manufacturing costs. We only need 1 of them. Well, I can select the faces associated with one of those supports and hit delete, and Fusion will actually patch that geometry out for me. But more than that, I can actually now move the existing one into the center so that this thing looks symmetric. It doesn't look funky with it all off-center like that. So I can grab this and just rotate it now 30 degrees into the center of the model, and I've done all that with 0 feature history on an imported model. So I'm going to save this thing. I like the way that that worked. I can say made FEA edits. It's going to put a version up there and do all that fun stuff that it does. And when I swap back to the assembly, you guys are going to see something that you're definitely not used to. So if I make this change, whether this was a change anyone knew I was making or not, anyone who was consuming this in a downstream assembly is automatically going to get my updates the next time they open their file. In Fusion, it says, hey, one of your component files has been updated and the version you're using is out of date, but we're not going to force you to consume that data because that may be a change that nobody knew about and nobody wants. So we're going to let you choose when you consume that data. So I can come down here to the gear housing, I can right-click and I can get the latest version, and I can go pull in the changes that my colleague has made. If I don't like those changes and I don't want them, I can actually right-click on that file and choose a different version, and I can go back down to a version that I knew worked in my assembly. In this case, this still works, so it's not a problem for me, but we've all done that thing where we saved an assembly Friday night, we opened it Monday morning, and it blew up because somebody made a change to a component. That doesn't have to be an issue anymore. Now you can go back in time and you can utilize the state that you know was working. And so here I am, I've made those changes. Obviously, if I go into my simulation environment, I can rerun, and this will give me new results based on the changes I've made. So I didn't have to set anything up. The constraints, the loads, the mesh settings, everything is still there because it's all in the same environment. And now it's just going to recalculate with the new geometry, and hopefully this has solved the issue for me. So we go look, a 1.11 minimum factor of safety. It's not going to break, but it's probably not necessarily as strong as I want it, but it's better than it was before. So there you go. In that single environment, I've been able to fix that. And so if I take a look at the impact of all this stuff in terms of the cloud, let's say we finish the FEA study here as we do a save. This is going to bump to version 6. If I go over here and I click on the project name, this is going to take me into the project page in the cloud. And this is just Google Chrome. Okay, so here I am in Google Chrome. I can see who's in the project with me. I can see activity in the project, right? So I can see that Sam had commented, John updated the gear housing. It's sort of like a social media feed. I can see pictures of all the files that are in here or the details, and I can start to go into these files. Now this is still saving, so it hasn't generated its thumbnail image yet, but in this particular model I can see things like the versions. Here's all the versions I created automatically saved for me, and I can go back and I can look at any of these old versions if I want to, right? I can even promote the old versions and make them the latest version. I can see any comments that have been made on this particular file, so you can see the comments that Sam and I did earlier. I can browse into any of the child components if I want to do that. I can also browse up level and I can see the parent components. So if I'm in a child component, I can see the parent components and I can go back into the parent component now, right? I can see that a simulation was run. A rendering was created. This is that cloud rendering that we asked for earlier. So that cloud rendering has been created for me automatically. If I load the simulation up, I can actually view this in 3D in Google Chrome. So I don't need a special viewer. I don't need to download the model file or anything like that. I can view this 100% inside of Chrome, and we can see the results that get mapped to this thing here inside of that model. Or I can view the whole model, right? I can come in here and I can just view in 3D the entire model, and I don't have to worry about the simulation. I can just see everything. And again, this is no download, no install, running directly in my viewer. So there's everything in 3D. You can see even the rendered appearances come through. I didn't put an exploded view in this model, but part of this viewer is spherical exploding algorithms. So I can turn on the explode and I can explode this model. But more than that, I can actually mark this model up. So if I come in here and I realize, hey, there's draft on this one and not on those two, let me make a note back to my designer and say, hey, you know, I want to make sure that you actually draft these two ribs as well. So I can do full on-screen markup in here with text. And this will go right back into the comment feed. So John in Fusion would get this note that whoever made, and you can see it in the comment feed here, and we have full history of these comments inside Fusion. And the cool thing about this is that if someone's in here looking at a different orientation and they click on that markup, it's going to take them right into the view that I used when I made that markup. Okay, so one last thing that I want to show here. This is awesome for people that you've invited to your project and you want to give this level of access to. If there's people that you just want to share the files with, you don't necessarily want them to mark up or anything like that, you can create a share link that will give you a URL you can send to them that they can open in their web browser. So now I email you this URL, you go open it in your web browser, and you've got the full 3D viewing capability of the model that I sent you the link to, but that's it. You can't access anything else in the project. All you can access is the model that I gave you the link to. It's still the full 3D viewer, so you can come in and rotate this thing around and see it in 3D. You've still got the explode capability, but markup capability is gone now. And if you choose to, you have some other options. You can turn on download. You can also turn on password protect. And so if download is turned on, the user can actually choose the format they want to download it in. So say you're sending it to two different machine shops for quote, one guy wants an IGES, one guy wants a step file, you can send them the exact same link and they can choose the file format that works best for them, and you don't have to worry about generating all the different files. This link is also live, so if they say, hey, I can't manufacture this unless you put a notch there, you go into Fusion, you put the notch, you hit save, they reload the same link. You don't have to send them a new link, and they're going to see the file with the notch in it now. So the ability to collaborate both internally and externally with this cloud connection real time is something that no other CAD tool has. This is just a really huge advantage to Fusion on top of everything else that it has. So there's a lot of other stuff that I can show you. I want to pause now and be able to answer any questions that anybody has. I will point you to a couple of things while the questions are coming through, and that is that in Fusion there is a really complete learning section. So you can go to Learn Fusion 360 and you can see all sorts of tutorials and everything to help you learn how to use Fusion. We also have an Autodesk Runs a Fusion 360 YouTube page with even more advanced tutorials on it if you're interested in some of the more advanced topics. There is also a Submit an Idea and Product Roadmap link. And this is great because you can go to the product roadmap, you can see the features that we're working on and when we expect to have them available. You can also submit your own ideas and have those potentially show up in the product as well. Last thing I'll mention is that being a cloud connected software, we actually push the updates via the cloud when they're ready, so we don't necessarily have to wait every 2 months for a service pack and then ship the whole product. If we have a new update that's really great, we can push it out Tuesday morning when it's ready. So you see a lot of development speed happening in Fusion that you don't get in other tools. It's actually very cool. So I'm going to stop talking now, and I'm going to answer any questions.
Thank you, John. Thank you. I don't know what's more mind-blowing, the features of Fusion 360 or the price. It's really, go take a look, at the product on the Novedge page, and you'll be like shocked what a great deal it is. I just sent you a question, John. I don't know if you can see it, but I'll read it to you. Can you hear me?
Yep, I can hear you.
I'm very curious how well you can go from STL files exported from ZBrush and then convert that geometry into something that is easy to use for 5-axis milling G-code.
Yeah, so that's actually a really great question. Unfortunately, STL files are meshes. They're not actually real CAD data. And so when you bring an STL file into a CAD system, and this includes Fusion, there's not any sort of modification, manipulation that you can do with those Fusion files. However, Autodesk makes this really awesome product called Remake. Right? Autodesk Remake is the name of the product. You can utilize that product to convert your STL file into an OBJ file, which is a similar mesh file. But one of the options OBJ has is that you can use quads instead of tris. So STL files are triangles. OBJ files can be triangles or quads. They can be squares. And so if you translate that file into quads, you can then bring it into Fusion utilizing the sculpt environment. The sculpt environment can insert a quad mesh, and then it can convert that to a T-spline. And then once it's converted to a T-spline, you can utilize all the tools in Fusion for smoothing and everything to have a nice continuous solid body instead of a bunch of faceted faces, and then you can do your tool paths on that solid body. So there's a couple of videos up on our website about how to do that. They're on the Fusion YouTube page if you're interested in it. It's a very, very cool process, and we've actually done it quite a bit with customers, so that it comes up quite often.
Cool. Thank you, John. So I sent you another question, but it's, while we're talking about T-splines, this attendee wants to know, okay, what is, Fusion, looks like T-spline has been incorporated by Fusion and there's no talk of an upgrade path. What are the options, and if you know what's going to happen?
So I'm sorry, you'll have to clarify,
Okay.
an upgrade path from what?
Okay, so for T-splines.
Yeah, so is this the user, whichever user asked this question, are you a T-splines in Rhino user?
Yes, yes.
Okay, so I can't for sure say, right? T-splines in Rhino was something that T-splines wrote before Autodesk acquired that technology. If I had to take a guess, I would say there's probably no reason for Autodesk to continue supporting T-splines in Rhino since we have our own product, but that's just a guess. There has been no formal decision or anything made on that. I can probably for sure tell you that even if they continue to support T-splines in Rhino, you're not going to see any enhancements to that plugin. But if you have a T-spline in Rhino, you can insert those T-splines into Fusion and then continue manipulating that T-spline in the Fusion environment.
All right.
So hopefully that answers your question.
Yes. And the same attendee says that it works as a digital sculpture with focus on large-scale public art fabricated with laser cutters and CNC milling. And he was wondering what are some features that would interest him the most in Fusion 360.
Well, I mean, I think that given that background, one of the things that's got to be the most interesting for you is the ability to connect the sculpting environment straight to the CAM toolpaths. If you're doing this using Rhino right now, you're creating surfaces in Rhino and then you're bringing it to some other CAM product, and you're hoping that you have uniform, watertight, closed boundary surfaces that you can put toolpaths on. And that may not always be the case. So with Fusion, you're going to be able to do completely closed, watertight surfaces using T-splines, and then move that immediately into the CAM environment in the same product, set up your tool paths, and then if you go change the T-spline model, your tool paths will automatically update, so you won't have to reset anything up from a CNC perspective. So that to me is probably the most exciting thing for you in that particular realm.
Cool. I hope that helps. Can Fusion 360 export quad only OBJ watertight files that can be opened in ZBrush? Is that the only?
Unfortunately, no. So right now we don't have any OBJ exports, but actually if you go and you look at our roadmap, you will see that OBJ export is on the roadmap. Currently, all that I can export from a mesh perspective is STL files. And in fact, you know what? We just got an update a few days ago. So let me check the other export options. It could be that OBJ is in here. No, still no OBJ. So OBJ is coming, it's on our roadmap, but other than that, we have, regular typical export options for solid bodies, and then STL export for if you want a mesh body.
Okay, and Fusion is a standalone installation on both PC and Mac, right?
Yes, correct. Okay. It's about a 300 meg install size. And then all updates are done automatically. So if we push an update on Tuesday night, when you open it Wednesday morning, it does the update automatically.
Fantastic. And then there's one of our viewers that says, so does that mean that AutoCAD and Inventor will disappear?
So I would say that's a really good question. I don't think AutoCAD is ever going to go anywhere. I think that at some point, and we're talking probably 10 years down the road, but I think at some point Inventor is going to go away because ultimately the architecture that Inventor is written on is an old architecture. It can't support things like full multi-threading, right? So at some point, when Fusion eclipses all the functionality that Inventor has, and don't get me wrong, Fusion's a great tool, but Inventor can still do things Fusion can't do, like sheet metal and framing and stuff like that. But when Fusion surpasses Inventor, I believe that this will be the product of the future in our mechanical space. So I would expect some number of years down the road for Inventor to go away.
Okay, there you have it, folks. And I think this is it for questions for now. So I'm going to take the screen back and let me see if you can see my screen. I want to thank, first of all, John for a fantastic presentation and Q&A. And I want to thank you all for attending. And please go check out Fusion360 on our webpage at novedge.com. And I can believe you can have all this for this much. And that's the real thing, guys. So Novedge is the best way to buy design software online. And for information on the latest specials and new releases, join the Novedge network on Facebook, Google+, or Twitter. And don't forget the next week webinar will be about organizing your document set with Bluebeam Review. And to rewatch today's webinar or previous ones, check out our Novedge YouTube and Vimeo channels. Our webinar playlist has webinars for every software taste. Thanks again for joining us today. Thank you, John, and have a great day, everyone. Bye-bye.